Cool. Yes, so we have talked about domain and range in the last class, and now we need to talk about so let's do some quick problem, and then I'll start with a graph. Okay. So if you have a function, let's say f of x equal to mod of x minus 1 plus mod of x plus 1, then what is domain and the range of this function? Calculate it and do it fast. There is another question. F of x equal to log of x square minus x plus 1. I think I have done this problem. I don't remember. Maybe. Uh, yeah. Let's make it more complicated. Yeah. Yeah, do it, guys. What's the answer of the first one?
Domain is minus infinity to plus infinity.
Yeah, yeah.
X can be any value, and range is
Range is?
from 2 to infinity.
Why it should be 2 to infinity?
So any value you put, the minimum is coming to be 2.
Mm-hmm.
So that's why for 0 it's 2, for 1 it's also 2. So that's why. I think it should be
Cool.
positive, that's for sure, but I think it should be, minimum should be 2, I think.
So how do you start with this kind of problem? Let me tell you. What you do? Your problem was x minus 1 plus mod of x plus 1. You go on the number 9. You make this 0 and this 0. This is how many points did you get? 2 points, minus 1 and 1. Okay. Now, what exactly you should do? You should open up these mods. So you guys know how to open up mods. Mod definition says if you write mod of x, then it is goes minus x and x minus x when if x is less than equal to 0, if x is greater than 0. Okay. Now, what exactly we need, how exactly we are going to open up it up using this definition? We will write when x is less than minus 1, less than equal to minus 1, then your first term is going to be open as negative of using this definition. Minus of x plus 1. This is actually also going to be negative of. Why? Because it is also first term is 1, and it is also going to be negative of that one. So minus of x and minus 1. So you get minus 2x, right? then when your x is -1, in between -1 and 1. So what is your first term? X minus 1. And what is the root of this one? 1. So your x minus 1 is actually going to open as negative of this term. Just one thing keep in your head, that exactly where you are right now. Or one of the tricks that could be that if once you just go on the number line and divide the interval. So you have three intervals, right? First interval, second interval, and third interval. I started with this interval. Take any point below this, any point in this interval, or any point in this interval, and just plug it in and see what exactly you are getting. If you are getting a negative number inside, then open these terms with negative, multiply with minus sign and open it up. If you get a still negative number or positive number, then open it up using this definition. Same definition that you will have to use in each interval. And if you get positive, then open it up using this definition. Okay. So, am I making sense? First of all, tell me that. Or I think you guys know already.
Sir, can you repeat it again?
Okay. So what I said, that first, what exactly you do, you go on the number line. You know that how do you get -1 and 1 on the number line. You exactly use this term and x minus 1 term and figured it out that what is the 0 or what are the value for which these two terms are going to be 0. So first term is x minus 1. That is, when you put that equal to 0, then you get x equal to 1. When you put x plus 1 equal to 0, then you get x equal to -1. So basically you got two values. Now you go on the number line and you just point out those two value, mark it. Then you see that your real number line is actually divided into three parts. That you can see that, right? Guys, I need a response at least.
Yes, sir.
Okay,
Yes,
so
sir.
that, so real number line is actually divided into three intervals. After that, what exactly you're going to do, you take any point which would be suitable for you to calculate the values. So I took -2, 0, and 2. So in this interval, third interval, which is actually less than -1, wait a minute. Yeah. So in this interval, this is the third interval, I took a point -2. I plugged it here and here. So if I plug -2, what exactly do I get here? -3, right? If I plug -2 here, what exactly do I get? I get -1. So see the result inside this term, after plugging -2, you get negative. That means that you will open it up with this negative x. That means what I did, I used minus sign here. After when I'm opening the mod, I'm multiplying it with -1. That's all you need to know. When inside term is negative. So minus of x plus 1, minus of x minus 1, and you get -2x. That is your function. Where? When you have x is less than equal to -1. Similarly, you do with the second interval. Similarly, you do with the third interval. So here you will get, first term you will get -x plus 1, and this term is going to be positive if you put 0, because that is 1. Then you will get plus x plus 1, and that will be 2. When x is greater than equal to 2, you get everything positive, because if you substitute 2 into these two terms, you will get, in first one you will get 1, and second one you will get 3. So you just open it as it is. So x minus 1 plus x plus 1, you will get 2x. So if you just draw the graph, right, -1, 1. And this is y equal to 2 line. Then your graph is going to look like this. Yeah, this would be more straight, so don't bother me regarding that. Yeah, but this is going to be 2x. This certainly has negative slope, that you can see that, minus 2x, and this is 2. This is y-axis and this is x-axis. How did I draw the graph? Simple. Using this. Okay. Now, what was the question 2? Yeah, so you need to find domain and range. Sorry, yeah, that I forgot. So domain would be R. I mean, you can see that there's no value in R for which you can't use that as an input. So for all values in the graph, you can see as well, or in the function, you can see as well. Like this is a polynomial function. This is a constant function. This is a polynomial function. Then yeah, this is basically these polynomial functions are defined at every point on the real or on real number. So what about range? So one way to find range is using the graph that you can see that. Another way to do that using the function. So this is a polynomial function. This is also a polynomial function with degree 0. This is also a polynomial function. So maximum it can go to infinity or minimum it can go to 2. As simple as that. How beautiful this is. Can you imagine? What was the second question? This is easy. Can anyone tell me what exactly did you get? What is the domain? I'm not going to solve it. Or can anyone just tell me the intuition? Not you, Nitya. You have spoken enough. I want to talk about you guys. Dipanshi, why do you think domain and range both are R? Is she not here? Jharna, go ahead.
So first we'll put x square minus x plus 1 is greater than 0.
Why it is greater than 0?
Because log of 0 doesn't exist, and negative numbers, log of negative numbers also doesn't
No, no,
exist.
no. X square minus x plus 1 is greater than 0. Why this particular term is greater than 0? That's all you need. You're right. But why it is greater than 0? Just tell me that. Mansi.
So because like मतलब हमेशा zero रखते हैं ना, why did we do that?
Simple, guys. Sarvjyoti. I'm giving you a hint. Tell me now. Come on. Now I can't give you more hint. Come on. Nitigya.
So their roots don't exist, right? Like for x plus
Yeah.
1,
So
the roots don't exist. exists. So I think basically for every value it's positive. So that's why the domain is IR. And
You're right, but say exactly what uh, you're not precise. You're not precise.
so the roots are, I think I can only think in terms of that. So roots are not real. So
Okay, let me tell you. Let me tell you what exactly why it is positive always, and I do not have to worry about any x. If you have a quadratic equation and the coefficient of x square is positive, that means one or whatever you just think coefficient of x square is positive, and determinant of quadratic equation is negative, then that quadratic equation will always be positive. That is the property of quadratic equation. This is always positive. So what you were saying that it doesn't have any root, it's totally fine. I totally agree with you. But the preciseness would be, yeah, this one, that the quadratic equation has this property for coefficient of x square being positive and determinant being negative. The equation itself will never be negative. Not just negative, it will always be positive. Yeah, because if you say that never it will be negative, that means you're also saying that it could be zero. So that's not possible. Yeah. The preciseness would be on this one. So do this. What is the third question? Third question is easy. I'm not gonna do it. Come on, just tell me the answer. I'll do the fourth one. What is the domain? It's quite simple.
minus infinity to -1 open interval.
नितिज्ञा, इतना बड़ा blunder. How did you do that?
Oh, sorry. I know. I made a mistake.
Mansi, what's the answer, Mansi? You guys are here, right? I'm not able to hear you.
So minus infinity to 1. Like, no, sorry, -1.
Square root. Look at the term 1 upon square root of 1 minus x squared.
Okay, fine. It's -1 to
1.
understand.
Just tell me open interval or close interval. I'm done with this problem. Jharna,
Open interval.
cool.
No.
Done. Why it should be open? Because the term is in the denominator. Be fast. And how are you guys going to be fast? I'll tell you right now after this. Let me just do it the fourth problem. What was the question? Yeah, x square minus. This is a trickier problem. You won't be able to find particular x. I mean, you can, but that would take a lot of time. But this is more or less graph problem. Now tell me, it should cut x square or not cut x square? Here, this is forget this one right now. Let's call it x naught. This is x square graph. This is e to the power x. How should it go? Anyone? The question is e to the power x graph should cut x square or not? after this. I mean,
No, sir.
no, why?
Because it's exponential. It's increasing. It increasing function and x. Okay.
You're right.
Exponential function is the most different.
That's what you're saying, right? The rate of
Sir,
change of e to the power x is
always greater than
yeah, always
anything.
higher than rate of change of x squared. That's what you need to use. Let's just say that this point is x naught. So in your domain, r minus that x naught point. To get that point, I think you need to use gamma function. So I'm not sure you guys know that or not, but yeah, if you are curious about it, you can read about it more. But yeah, just say it x naught point, or I mean, you can get a tricky question like these in ISI. So they ask sometimes. Okay, now let me go on graph. I haven't told you guys how to get maxima or minima. So just a short recap about maxima or minima.
Range is R, right, for the last one, 4th.
The range is going to be that point is not, and x square minus x square minus e to the power x will be when it is going to be infinity, it is going to be infinity, then it is going to be 0, negative side, and it is going to be 0, 0, 1. Yeah, it should be R. Just give me a second, I'll confirm. I just made this problem. I mean, that's my head always troubling with questions. Yeah, guys, it's R. My intuition was right, it's R. Cool. Do you guys know any math software? MATLAB, Wolfram, PLSSEM, any math software that you use?
Yes, sir, I know Wolfram.
Good, very good. Mansi, right?
Jharna.
Dharna. Sorry, yeah, very good. Wolfram is quite useful, but not more than MATLAB. If you are interested in macro, you will do MATLAB a lot. Let me start with maxima and minima. So what is the general process, guys? For maxima and minima, if you have a function, okay? So I'm just doing short recap. We will do it in details. Then what exactly you do, you find out the derivative of that function and you equate it to 0. And then you also calculate what would be double derivative at that point. And if you say that at that point, your maximum value, it would be the maximum value if that value is negative, because that would be convex. And if it is giving you a positive value, then it would be nil. So let's just do one example. If you have x squared minus 5x plus 6 equal to 0, 2x minus 5 equal to 0, x equal to 5 by 2. What would be the double derivative? Double derivative is 2, right? And which is a positive double derivative. I'm in the f double dash x. This is f dash x. And you plugged it at 0, then you got this point. So what is this point? Maxima or minima? According to this minima, right? Also, you can say that this is a parabola and this is going to have two roots, 2 and 3. This is your 2.5. So for this point, this is minimum value. Any doubt here? Guys, any questions, any doubt? It's too easy. Any question if you have? Otherwise, I'll move forward.
No, sir.
Cool. So, how to draw a graph quickly? In general, what exactly you do, if you have a function, first find out the points where this function would not exist. Okay. First thing you do, that you figure out the points where this function is not defined or it won't exist. Second thing, you find limit at these points. Limit at minus and plus infinity. And third thing you do, find out the value where function is going to be 0. Okay. And fourth thing you do, that would be one that you should do only when you feel like, okay, you're not getting the sense of this function. Then you should calculate the derivative. Usually I do not do that because I have practiced enough, but you guys haven't. So I would advise you to follow this step as well. And how are you going to do that? Let's take an example. So if I give you a function x minus 5 upon x plus 3, what do you think the graph would be? Come on, guys. Just tell me the direction, where should I move?
It wouldn't exist for -3.
Good. First thing. Point number 2, what was that? Look at here. What is the second point? Limit at these points and limit at plus minus infinity. Calculate those. What would be limit at minus 3 left side? That means this side.
Infinity at x equal to -3. This will be
Minus 3
infinity.
left side. I'm talking about
So,
LHL. You need to calculate limit at plus infinity, minus infinity, and minus at minus 3, both sides, LHL and RHL. Tell me the values.
-x plus 5 upon -x plus 3 for LHL of
Sorry. Let
-3.
me write that, Nitya. The limit x tends to minus 3 minus f of x is what?
-x plus 5, because it will be negative, right? The whole thing will become negative. So
Okay, okay. Anyone else want to take a shot? I should have taught you guys limit as well. I can see the struggle. I thought you guys knew. Okay, guys, I can't wait anymore. Anyone want to answer? Dipanshi, Mansi, Sarabjyoti, Sharna, it's open question.
So
No
it
one?
will be minus
Ah,
infinity to infinity.
minus infinity where?
At -3, it will be
Guys,
shortly.
wait. See here. When you calculate limit x tends to -3 plus, okay, your function is x minus 5 and x plus 3. What exactly you are doing? You're putting -3 plus here, plus 3 here. So this value is going to be positive or negative. You're here somewhere here, this side. This is minus 2.99999 something. If you just add there, you will get a positive value. This is actually negative value, which is actually 2.999 minus 5. And this is something positive, then this is going to be minus infinity. Here, similarly, if you want to do it like properly, then you should write -3 plus some sort of h, and then you do it like using this method that this is going to be -8 plus h divided by h, then it is going to lead to minus infinity. That's all. I mean, that's how you should do it properly. But I'm giving you intuition that how fast you can think in terms of numbers. So what exactly RHL mean? That if you are just going slightly a bit right side on to -3, and you're taking a value something like -2.9999998 or something like that, your edge is very small that it will lead to a disaster in minus infinity. So that's how you get minus infinity. Similarly, you are here going to get plus infinity. So forget about that axis. Your graph should be something. Yeah, sorry about that. One more thing. Limit x tends to plus minus infinity. Whenever you have polynomial, you know how to find limit. First thing you do, you check out if this is a rational function. You check out the maximum value of degree of x in both numerator and denominator. If they are same, then their coefficient a upon b is going to be the limit. So here a and b both are 1. That means the limit is going to be 1 at both plus infinity and minus infinity. So basically, this is y equal to 1 line. This is y-axis. This is basically x-axis. This is x equal to -3. Since your LHL is plus infinity, that means that value is going to be plus infinity and it will tend towards 1. Here, yeah, something like, I mean, it should be more. Wait. Why if it's not gonna, then I'll just, I meant to say that this should be something like this. I hope you guys understand. Yeah, just asymptotically at x equal to -3. So it will never touch this vertical line, but it will go just like this. Yeah, and here it will go like this. Okay, so I can see the struggle. Let's do limit and then we will come back on this. So you guys want a 5 minutes break? You guys want to drink water or something? guys?
Sir, after this.
Okay, just take 5-minute break.
Okay, sir.